In this video, we're looking at TOA, which is right-angled triangle trigonometry. Essentially what this means is that you've got three things that you care about on a triangle. That's two different side lengths and one of the angles. And you can find the third thing, whatever that happens to be. So your first step is to label the triangles. So you label them hypotenuse being the longest side. The adjacent is the one that's sort of next to the angle, but not the hypotenuse. And then the opposite is across from the angle, just like that. Now the adjacent we don't really care about on this triangle because it's not a side we know or a side that we're trying to find. So we're looking for a trig ratio here that has the opposite and the hypotenuse. That's going to be our first one here, sine. So we can write in sine of theta is opposite over hypotenuse. And then we can put in the 2 out of 3 things that we know. So we do know what theta is, that's 17. By the way, if you're wondering about this symbol, theta is how you pronounce it, and it's a Greek letter. Opposite was 2, and the hypotenuse was just a question mark here. Although I might actually just call that x, just to make it a little bit nicer and algebraic. Okay, so we can rearrange this. So first thing we're going to do is we're going to be timesing by x to both sides. So I'll be left with x. Sine of 17 is 2. And then what we want to do is divide by sine of 17 on both sides. So you'll be left with x is 2 over sine of 17. Now, once you get used to trigonometry, you can do this in one step, just essentially swapping those two things whenever you see like an algebraic situation like that. But now that we've got that, it's just a matter of putting this into a calculator. So you want to make sure you're in degrees. So this is shift setup and go down to measure the angle in degrees. So that's F1. If you're not sure whether you're in degrees, you can do something like sine of 90. And as long as you get 1, then you should be all good. You're in degrees. Radians is just a different way to measure angles, which we'll learn about soon. Okay, so we want 2 over sine 17. We can chuck that into a calculator. So we'll go 2 on the top, and we'll go sine of 17 on the bottom. You're going to get 6.84. Let me just do a sanity check for a second because 2 is on there. The hypotenuse should be the longest side. So you've got 6.84, which does make sense. Next triangle we've got, I care about the adjacent and I care about the hypotenuse. So I care about those two sides. I don't really care about the opposite there. We'll call this question mark thing x again. And so you're going to get cos of theta is the adjacent over the hypotenuse. So because we got adjacent and hypotenuse, we're using this ratio because this is the one that doesn't have opposite in it. Okay, once we got that, you're just going to say that cos of 33 is the adjacent, so that's x over 5.2. Now this one here is actually the easier one to rearrange because all you need to do is times by 5.2 to both sides. So you're going to get 5.2 times cos of 33 is x. So x is whatever the calculator spits out for that, which we can just quickly work out. 5.2 times cos of 33. Cool. There we go. 4.36. We'll make sure that it makes sense. 5.2 millimeters is the longest side, so 4.3 does seem like a good sort of side length. If I got 500 millimeters, I know I'd be in trouble. Okay, this one here, 4 and 9, so we need to work out the angle. Let's start by labeling. So I've got the adjacent to the angle, and I've got the opposite to the angle there. The one that we don't have is hypotenuse, so we're after the tan ratio there, because tan is the one that doesn't have hypotenuse. It's got opposite and adjacent. So we'll look at this. Tan of theta is opposite over adjacent. So that tells us that tan of whatever theta is has to be 4 over 9. Now the way we rearrange this, I'd like theta on its own. So if you rearrange an equation like 2x equals 1 or something, you would be dividing by 2 on both sides because that's the opposite of timesing by 2. If we want theta on its own, what I have to do is I have to tan inverse both sides. So essentially that will just leave us with theta over here because if I write out what the full thing was, it's tan inverse of tan of theta. So those two will just cancel out. On the right hand side, I have to get tan inverse, because I have to do it to both sides, of 4 over 9. All right, now we can just chuck that in a calculator and see what we get. Tan inverse, 4 over 9. And you get 23.9, or 24.0 degrees to 3 significant figures. Cool. And we just make sure, does that make sense for an angle measurement in a triangle? Yes, 24 degrees is about what you'd expect to see in a triangle.